This lesson is all about factoring the difference of squares. So we're given a binomial stated a squared minus b squared, and this is called the difference of squares. Why is it called this? Well, each part of the binomial, each term, a squared, b squared, you can hear me saying the word squared. These are squares. They're being taken to the second power. And then we've got this subtraction sign in here. Subtraction, taking away, it's another word for difference. So we've got the subtraction of x, like things being squared, exponents of 2. So when you see this binomial, if it's a difference and they're perfect squares, then you can factor it. First of all, we need to know what some of our perfect squares are. Perfect squares are numbers that we can take the square root of. So we can take the square root of a number, a perfect square, and we'll get a whole number in return. So 1 squared, it equals 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. I highly recommend that you memorize these, because when you see one of these numbers, these are called the perfect squares, and we know that if we take the square root of any one of these numbers, we can find a whole number as our answer. So if I give you a squared minus b squared, the rule is that we can factor it into two factors, two binomial factors, and it's going to be whatever number is being squared, so that would be a and b, and it would be a plus b and times a minus b. Now remember, order doesn't matter of the factors, so this could also be a minus b times a plus b. But this is the rule for factoring difference of squares. If I am given a binomial, I can take it into two factors, each number that's being squared plus and each number that's being squared minus. So a plus b times a minus b. So let's look at an example. We have a squared minus 9. We want to find what a is and we want to find what b is. What number or what variable is being squared each time? So here, you're kind of looking at what can you square to get x squared and what can you square to get 9? Well, hopefully you're thinking to yourself, x squared is x squared, and then 9, it's one of our perfect squares. The square root of 9 is 3, so that means 3 squared is 9. Therefore, my a is x and my b is 3. You don't need to write this out every time, but it might be helpful while you're getting used to this. So therefore, my factored form of x squared minus 9 is a plus b, so x plus 3, times a minus b, or x minus 3. This is my final answer, x plus 3 times x minus 3. We can check over our answer by foiling. If you FOIL, first is x squared, outer is negative 3x, inner is positive 3x, and last is negative 9. This simplified, you see that these cancel out and we're left with x squared minus 9. So looking at x squared minus 81, remember we're looking for what can be squared to give us x squared minus what can be squared to give us 81. Well, the square root of 81 is 9, so 9 squared is 81, and x squared is x. So our final answer for this question is x plus 9 times x minus 9. Looking at another example, we have 2m squared minus 50. Well, if you notice, 2 is not a perfect square, and 50 is not a perfect square. So I'm going to give you a hint that I want you to write down. Always, and we've said this before, we're going to say it again and again, always factor out a GCF first, if possible. So if there's a GCF, you always want to take it out first, if you can. So let's look and see if there's a GCF here. We have 2m squared minus 50. We notice that 2 can go into both of these, and we get m squared minus 25. That leaves us with this final answer, 2 times m squared minus 25. Well, now looking at m squared minus 25, we have a difference of 2 squares, because the square root of 25 is 5. So this can factor out even further into m plus 5. So 2 times m plus 5, m minus 5. Sometimes this answer might not be able to factor any further, but at least you've taken out a GCF. All right, looking at this example, we have 16x squared minus 49y squared. I want you to take it into two parts. What squared gives you 16 and what squared gives you x squared? Minus what squared gives you 49 and what squared gives you what? What squared gives you y squared? Well, hopefully you're saying to yourself, 16, the square root of 16 is 4. So 4 squared gives me 16 and x squared gives me x squared. Square root of 49, that's 7. These are my perfect squares. So minus 7 squared times y squared. Well, this also means that I have 4x squared minus 7y squared. So my a is going to be 4x, my b is going to be 7y, and my factored form is going to be 4x plus 7y times 4x minus 7y. This is my final answer here. All right, looking at another example, we have x squared plus 100. I want you to pause the video and see if you can answer this. All right, so some of you might have gotten x plus 10, x minus 10. Some of you might have gotten x plus 10 times x plus 10. Some of you might have gotten x minus 10 times x minus 10. It's good to see that you knew x and 10 were your a and your b. But let's FOIL these out now. X times x is x squared minus 10x plus 10x minus 100. These cancel out, and I'm left with x squared minus 100. Is that my answer up here? No. Therefore, this doesn't work. Looking at the next one, we have x squared plus 10x plus 10x plus 100. Well, I now have my x squared plus 100, but unfortunately I have x squared plus 20x plus 100. Does that match my original? No, it doesn't. So this doesn't work either. Finally, I have x squared minus 10x plus 100. Again, I have my x squared plus 100, but unfortunately I have minus 20x in there too. Does that match the top answer? No. So this doesn't work either. The reason why none of these answers work is because of this plus sign right here. Remember, this lesson is on the difference of squares. That's two squares being subtracted from one another, not added. Therefore, there is no way to factor this, and we're going to call it prime. That's our final answer. The answer is this is prime. All right, I want you to pause the video and try these 3 problems on your own using what we've already covered. Okay, looking at the first example, we see x is being squared and 6 is being squared. Therefore, our answer is x plus 6 times x minus 6. Congratulations if you got that correct. The next one, we have 3x squared minus 12. Well, 3 is not a perfect square, nor is 12. However, hopefully you noticed that there was a GCF of 3. If we divide each term by 3, because we've taken it on the outside, we're left with x squared minus 4. Well, can x squared minus 4 be factored further? Yes, it can, because we have x squared minus 2 squared. So my final answer is 3 times x plus 2, x minus 2. Congratulations if you got that one correct. Finally, we have 49y squared. Hopefully you saw 7y was being squared and 8z was being squared. Therefore, 7y minus 8z times 7y plus 8z is our final answer. If you got all 3 of these correct, I think you understand how to factor difference of squares. Looking at one more example, I want to show you how you can apply this rule. Hint, this question shows up on the final exam every year, so it's important that you understand how to do it. So the area of the rectangle below, which you'll see on the next slide, is 81x squared minus 4. They want you to find the factors that could represent the length and the width. Previously, we've been given a base and we've been given a height, and we've been asked to find the area. So we would say area equals base times height, and we would multiply to get the area. Well, now they're saying the area is 81x squared minus 4. I want you to find the base and the height. Well, notice the way that I've written this, I have 2 factors. How can I take this area and get 2 factors? By factoring. So hopefully you noticed we have a binomial here. 81 and 4 are both perfect squares. So I see that I have, I have 9x being squared and I have 2 being squared. Therefore, 9x plus 2 is one of my factors, and 9x minus 2 is my other factor. I've factored the area, so if I was to multiply this out, 9x times 9x is 81x squared, then 9x times negative 2 is negative 18x, 2 times 9x is positive 18x, the middle terms cancel out, and 2 times negative 2 is negative 4. Here's my base, here's my height. Obviously, it doesn't matter which one you call which. The important thing is that you understand one factor is your base and one factor is your height. Very good. We're now done with factoring the difference of squares.